Welcome back from the break. So picture the scene. It's 2 a.m. and a groggy IT support technician stares bleary-eyed at his monitor, having just been woken up by an alert that the site is down. What's a typical way that he might address his problem? Oh, I know what it is. I'll delete that dodgy web pod. Or maybe if that doesn't work, he'll decide to restart the whole web service. And if it still doesn't work, maybe he'll rerun the deployment pipeline. And then he'll probably blame the developers because it's their fault anyway and file a bug for the morning because it's not that urgent. A Microsoft operating framework study in 2001 said that orgs with the highest service levels rebooted their servers, it's quite an old study, 20 times less frequently than the median. Things go wrong, and often we don't have the information at hand that we need to understand the problem. We often provide not enough metrics or information, or maybe too many metrics of the wrong kind to see what's really going on. So this talk is a little bit about the big picture. Telemetry enables us to get the big picture. We don't necessarily know what the problem is. It could be maybe a failure in the application, a defect in the code, a failure in the environment. Maybe there's a networking problem or a configuration problem. Or maybe something completely external, like a massive denial of service attack is underway. Looking at a more modern study, the 2015 State of DevOps report said that high performers can resolve production incidents 168 times faster than their peers. They have a mean time to repair or recovery of minutes versus days in the median. And what are the top two practices? Well, the first one is something you've heard me banging on about before if you're a regular at .NET, and that's version control for DevOps. The second one is telemetry and proactive monitoring. So I'm going to talk a little bit about telemetry today. So the first thing you're looking at here is a picture of a typical dashboard. Dashboards should be designed to show what's most important. All too often we throw up dashboards that contain purely technical metrics that don't really translate to the business that we're running. So this is a community Q&A site that shows health related to its purpose and not technology. You're looking at topics. You're looking at topics that don't have answers, topics that have been answered. So it's really relevant to the problem that the software is trying to solve. So creating monitoring like this, creating metrics like this, these should be introduced as requirements. Dashboards like this should be part of the product, and they should be available for developers to work with. And if you just look at something as simple that has matured over the last few years, like the improvements that we've made to logging as structured logging has coming along, just how much did switching to tools like Serilog, which let you run tools like Seek locally, make a difference in improving how quickly you could fix problems? But there is a challenge, and that is the amount of tools are out there, the variety, and in some cases the cost of them, the amount of different ways of configuring these tools and leveraging them. It's a real mess. In terms of the vendor space, you've got things like Signal Noise, Splunk, Dynatrace, Azure Monitor, formerly known as App Insights, New Relic, Datadog, Loggly, Honeycomb, Lightstep, Elastic, and these are the big names, right? There's tons more out there as well. So where do you start? How do you make these things work together? And if, for example, cost is an issue, how do you get these tools uniformly available across all of your environments? Because if this is going to be an important part of providing a quality offering and a quality solution, then you need to have it available to you. You need to have the information available to you in every environment. So, hi, I'm James. I'm going to talk today about open telemetry, and specifically open telemetry in .NET. What open telemetry is trying to do is bring some standards to this mess. It's an emerging standard that has pulled together a lot of the thinking in this space, that has got tremendous support from vendors in the space. It promises to give you one standard that makes it easy to plug in a variety of different backends to do monitoring. So it's not in itself a monitoring solution. It's a set of APIs and a framework to allow you to connect monitoring solutions to your code in a simple and pluggable way. So it gives you a single vendor-agnostic instrumentation library per language with support for both automatic and manual instrumentation. As well as being a specification, It also provides you with a binary called a collector that can be deployed in a variety of ways to act as the place where you send telemetry to and broadcast telemetry out to your various vendor back-end solutions that you might have in place. And it's an open standard. And as I mentioned, it's being very widely adopted, heavily contributed to. And in the .NET space, much of the framework has been implemented. There is pretty much at least pre-release versions of everything that I'm about to talk about tonight. It's getting very mature, it's very usable, as you'll see. And I'm going to get to presenting you some working code, which I will have available on my GitHub. In fact, it's already available on my GitHub, that you should be able to take home and run the exact same demo I'm showing you now. But before we do that, just going to get a few bits of terminology out of the way. So what is telemetry? There are sort of three legs of the triangle that make up telemetry. The first is spans and traces. So a span represents some individual operation within your distributed application. It will have a start and a finish, carry a name. It can carry some event information, some timing information. And spans are typically viewed and collected together inside of a trace, which is often presented in a waterfall diagram like this, where you can see at the top the root span, which describes an entire operation end to end, and then underneath that the constituent parts that make up an operation. So perhaps, for example, you're looking at the start there, or the duration of an entire API call, and you're seeing how the implementation is calling into various services, running through code, talking to a database perhaps. And this is an absolutely vital visualization for a modern distributed application that's touching many, many different pieces. Have you ever had a developer in the face of a bug that said, oh, I don't know, maybe it's the database being slow? Why don't you know, right? Use this tooling. You can see immediately that the database is fine. Of course it is. It's always your code where the problem lies, let's face it. Right? And maybe it's a service bus problem, but traces will tell you that. And the vendor support for this doesn't just go to the back ends that are storing the telemetry data. It also extends to many of the libraries that you use every day. For example, there's a .NET and many Azure fans in the audience. Many of the Azure SDKs will out of the box provide support for tracing technology. In fact, Microsoft has been massively ahead of the game here for many years, because the underlying technology that's being used to drive this in the .NET space comes from diagnostics that have pretty much been baked into the operating system from the beginning, and they've provided a shim that adapts the existing technology into the Open API specifications. And it works very well. Okay, so traces and spans are the first sort of leg of the trident. The next leg is metrics. So metrics in Open Telemetry come in three forms. You have counters, measures, and observers. I won't go too much into the details of this, but I'll give you a couple of motivating examples. So if you're creating an API, one of the key requirements going into any API design should be thinking about what's your service level objective for this API. You should have in mind some idea of some response time, for example, that you're going to hit. So in order to test that you're doing that, you might want to build a histogram metric which will capture 3 buckets of information. The 3 somewhat arbitrary, but it's a good recommendation, where you have a bucket that is based to capture response times that fall within the window that you're aiming at. And then the next bucket up should be 3 times longer than that, and the final bucket up should be outside and beyond that time span. That's a good compromise in terms of giving you enough information to be actionable. You don't want to create 16, 20 buckets, because it's not really giving you anything useful. What you want to know is, are 99% of my calls coming in at least as good as I said that they would? So that's a good example of a metric. A simpler example might be a counter that is telling you the number of questions that have been answered on your Q&A site. The existing standard around metrics has been, for a long time, has been led by a tool called Prometheus. So this is an example of how a metric might be named. So you can see on the beginning of this, you can see the name of a metric, API requests. We're looking at a total count of those. And then within that, you can see labels, which describe some aspect, some property of that particular count. In this case, we're breaking down our requests by method type, and we're looking at the API endpoint that's talking to them. And then Here you can see an example of a counter. Again, you see the name. Here we're looking at .NET GC collections, and then you can see a label giving you the generation and then the count of the number of collections of that type that have occurred. Right. So the third leg of the triangle is logs. We're all probably very familiar with logs. They've probably been around the longest of the lot as a developer tool. And actually, I'm going to show you a complete wire-up as an open telemetry collector. And it's not actually something I've seen on the internet. Because it's quite new, there are lots of different pieces demoed. And I've completely wired up logging as well as traces, which tend to be a bit of the poster child of open telemetry and metrics. But it's worth pointing out that certainly today, it's become definitely in the Linux space and increasingly in the Windows space, a practice to dump all of your logs out to the console rather than try and write them out from a separate file. And that's for a good reason. It's very easy in tools like Linux, particularly in Kubernetes, to capture the standard output into log files and then do your aggregation through tools that send the contents of files to a collector. OpenTelemetry very definitely supports that, but everything is kind of an equal citizen here. So you can send all of your telemetry feeds, all three of the types that we just talked about, into a backend directly from your code or into a collector. So let's talk a little bit about the various pieces, again, that make up OpenTelemetry. So you can see here we have an API. So the API, this defines the data types and operations for generating and correlating tracing metrics and logging data. This is the code. You use this API in your code to define the logs, messages that you want to write, the metrics you want to capture, and so on. And we'll look at using that in a bit. The SDK defines how you might implement code to generate those metrics. If you want to instrument your library and make that available to other people, then you would write out, implement the SDK. The collector is the binary that is the one thing, sort of bit of code that's produced as part of the OpenTelemetry initiative. That this is this vendor agnostic tool for receiving telemetry feeds and sending them out to backends. So it's worth saying that if you want to, you can plug what's called an exporter straight into your code. So you could have an exporter for logging to the console, and that would run very typically to the way that you write logging code today. But more typically, what you want to do with the collector is you'll run the collector as an agent, maybe as a daemon set in your Kubernetes cluster. So it's going to take the place of your vendor's agent today, and it's going to receive from all of the processes running on your Kubernetes node or on your server. It's going to receive all the streams of telemetry, and then according to the configuration that you've given that collector, it's going to send them off to various backends. And that's really useful, because maybe you're using a tool like Datadog, which is what we do at Imbursa where I work, to collect all of our telemetry. And it's a nice tool. It's a really nice tool. But it's very pricey, and it's very hard to run in a local environment. But with the collector in place, it's very easy to switch out your configuration without changing any of your code to send all of that telemetry to perhaps a locally running copy of Jaeger or Zipkin, and get all of the same information in a very easy to access place for a local developer. Okay. So collectors can communicate with various backends with multiple out-of-the-box provided exporters. So the binary that is produced has what's called a contrib version you'll see on your website, which comes out of the box with support with a whole bunch of different different vendor backends that you'll recognize. You can configure how those backends are wired up. You can process telemetry on the way through to perhaps attach a standard label to say what hosts and metrics are coming from. There's all sorts of toys in the box to alter and fix up how your telemetry is being received and dispatched. Okay. So this shows an example of some of the flexibility that you might have. Here you can see that we're running that OCollector binary on 2 different servers in its agent form, and in turn we're sending the metrics into an OpenTelemetry collector service, which is gathering together that backend, that telemetry, and then sending it off to here 2 different backends. So the backends, that would be something like your Datadog or your Prometheus and so on. And you might decide to send maybe all the metrics to Datadog, some of them to Grafana just to make a visualization there. It's your choice. And then your applications at the top here will be making use of the Open Telemetry library for your language to configure your logging, your metrics, and your tracing, and push them into the collector. Okay, so let's have a look at this in action. All right, so hopefully my code is big enough. So I'm going to walk through a couple of the key files in this source code. Again, I'm going to put the link up at the end of the talk so you can go and have a play with this yourself. So what we're going to do is we're going to run a collector and a whole bunch of backends, and then a very, very simple pair of .NET applications. They're going to create a trace, a metric, and some logs and push them into this setup. So first of all, we can see the configuration for the collector. And it's a very, very simple YAML file. You can see here that we're defining a receiver, which is going to use the Open Telemetry protocol to receive telemetry. So we're just exposing a standard gRPC endpoint that our applications are going to send their telemetry to. We're defining some exporters. So the collector is going to take the telemetry that you're sending it and farm it out to the exporters. And we're sending it out to Prometheus. We're sending out to a default logging endpoint, to Zipkin and Jaeger, which are both tools that can accept traces, to Loki, which is a Grafana-based tool that can accept logs. We're going to use a batch processor, kind of like you can imagine what this is going to do is as the metrics are going to come in, it's going to do a batching operation for efficiency before it sends them out again. We're going to run some health checks to make sure the system is running happily. And then we're defining as the core of our service what of the exporters and receivers and processors we're using for each of the 3 types of telemetry. So we can see here that we're configuring Zipkin and Jaeger to take traces. We're going to send our metrics out to Prometheus, and we're going to use Loki to send our logs out to. Okay. So to make it easy for you to play with this, I've created a Docker Compose file which contains purely the OTel collector and all of the backends. I've not put the .NET code into this, so you can lift that Docker Compose out, put it in your own project, and start using it. So I won't run through all of this in detail. You can do this in your own time. What I have done is locked all of the versions of the images here, so I know that this is a set that works. A lot of these are pre-release containers, but again, the stability is really good. I mean, it's good enough to start using, I think, in production situations. But it's pretty much standard builds of everything. It's very easy to put together. Everything is on standard ports, which I recommend because then that saves you doing a lot of configuration in your applications. And yeah, we're just running a whole bunch of backends plus the collector in this Docker Compose. Okay, so that's our place where they're going to gather telemetry, but how do we send telemetry to it from our .NET application? So there are 2 programs we're going to look at, techdemo.webapi and techdemo.client. They're both very, very simple .NET apps. So we're going to start here in techdemo.client. And what you can see here is just the boilerplate code in program.cs. We're creating some attributes, which we're going to attach to our traces that just name the host and the OS. We create a resource builder in which we name our service so we can identify it in our telemetry and wire up the SDK and give it the attributes that we've defined. This is going to help us identify the telemetry that we're collecting. We're then going to create a tracer. So that in this particular client, we're only interested in tracing. We're only sending tracing. And all we're going to do is new up an HTTP client. Don't do this in your production code. Use a factory. I'm sure that Nick can tell you more about that. And then we're just going to call our API. So that's all this does. And then I'm going to run that. It will make the call, and then it will close. So the web API is much more full-featured. In here, we're going to wire up all 3 of the things we talked about. So sort of similar intro to this, where we're creating the attributes and the resources. And then you can see we're adding in logging. And we're going to spit logging out to the console, as well as sending it to Open Telemetry. And there's a few things you can specify here. You can see I'm picking gRPC throughout this. We're wiring up tracing. We're adding a source because I've written some code to do some of the tracing here. And importantly, I'm relying on the automatically instrumented libraries that, for example, ASP.NET Core provide. But if I want to write my own spans, I have to tell the system to listen to them. Otherwise, you can write them and they won't get sent. So you opt in to sending your own spans. So that's what the source is about here. And then we're configuring metrics. To use metrics, you have to define what's called a meter. And on that meter, we're creating a very simple counter called myCounter. So there's one endpoint in this application. So we've used a minimal API here. It's just operating on the root path. And all we're doing in here is we're going to log a message. We're then going to call some async operation we'll look at in a sec, and then we're going to return an OK result containing hello world. So the operation down here is going to implement an internal counter I created. It's just a static int, doesn't really matter. The reason why we're running that counter is because we're going to blow up on exactly the third time that this endpoint gets called for demo purposes. So it's not really important to the code. I'm then going to create a custom span called foo. I'm going to add an event to that span. Spans have this kind of lightweight logging capability where you can attach events to spans. So we're going to add an event here saying doing some work. We're then going to sleep for a little bit, pretending to do some work. We're then going to figure out if it's time to throw an error. And if it does, we'll throw an exception, which will then catch, add another event, set a failure status, and record an exception into that span, giving us very useful diagnostic information later. And if it wasn't time to throw an exception, we're going to add another event saying that we're done and set an OK status on the span. Finally, before we go and leave the foo, we're going to increment a counter. So we're exercising, very briefly, pretty much everything that you might want to do in telemetry in an application. So that's the explanation. Let's see it running. So that script is literally just doing a Docker compose up on our back end. I'm just going to wait for it to get stable. Okay, and then we're going to fire up the API. That's literally just a .NET run behind the scenes. And then I'm going to run the client. So the client's going to make a call to that API and then exit. I'm just going to do it a couple of times. Now, if I fire up a browser, we're first going to drop into Jaeger. So you can see that Jaeger is already aware of these two applications. I ran this from fresh, so it's just picked this up now. And we can look, if we're going to look into the client and go find traces, we can see the two calls that I've just made. I can click into one of these, and you can see the lifespan of the root span here from the client, which made the HTTP call. You can see it coming into the web API. Now, and those of you who are observant will realize I only created one span on the API side of the code. That's because ASP.NET, with the automatic instrumentation, has created a span for me for the HTTP request. And then finally, you can see the foo span created here. So you can see that the path has been inserted for the request, and I named that foo span. If we click into one of these, you can see there's a whole bunch of additional information in here, giving me the method, the response code, all the kind of stuff you'd expect and want to see on an HTTP request. And you can see if we go into the process here, you can see we've got a whole bunch of information, name about the application. And if we drop right down into the child request, you can see there's a logs entry here where we've got the timing of the events that we raised. And all the times on this are offset with 0 being the start of the child span. So it's really easy to see when things happened and how long they took. And as we'll see in more sophisticated back-end tools, we can do aggregates over spans. We can see what's the average time a span should be taking. Is it longer than the average, and so on. So there's a whole bunch of stuff that we can do once we have this up and running. Now, just to show you the same view in a different tool, Zipkin is an alternative. Some prefer the UI, but it's an example of two different backends being deployed here. So you see all that same information, again, with all the annotations, the events, and so on. So now if I jump back to the code quickly and just run this client a third time, then it should blow up in this iteration. And if we come back to our traces, you'll see, in fact, just standing out there, we've got the red trace. If we jump in here, you can see the exception that wasn't handled has propagated back all the way up through the spans. And if we click into the span here and show the annotations, you can see that we've got the failure case. We can see that something went wrong. We've got the full exception trace. So tracing, pretty powerful way to get to the bottom of what's going on. So we've also got metrics and logs. So I've set up Grafana here to tell it about the backends for logs and for metrics. I've not created any fancy graphs, I'm afraid. I'm just showing you the raw data here. But if we run this query, then you can see here's all of the logs with the error highlighted in red that's come through from the application. And you could do fancy things like graphing the amount of log traffic you're receiving and do all the usual kind of log queries on this. And then for Prometheus, we can come into the metrics and we can see there's my counter that's appeared. And again, and actually, if you do want to know more about creating fancy dashboards in Grafana, I do have another talk, which I think there is a recording of from .NET Sheffield, and there is also a repo on my website which has all of the demo, all the .NET demos for building the Grafana dashboards. But there you go, you can see my counter has come through there. It's only got the 2 hits at the moment, and you can see all of the label information being collected for that. So, one cautionary note. You've seen that it's quite easy to create your own spans. Don't do that most of the time, because most of the time what you're trying to do here is collect a picture of the key things that are happening across your distributed application. I have seen traces that are an absolute nightmare to diagnose because somebody has gone and put 50 spans in their code against an individual request. Generally speaking, it's when you're getting stuff into your application and when you're pushing stuff out to dependencies that you really care about the time. Frankly, most of the time, the code in your application is the moral equivalent of walking to the bus stop versus a remote call, which is like a round trip to Pluto. If nothing else, it's really hard to look at those kind of spans in the tooling. You'll get this really sort of fine list of slices. And in fact, I did take a couple of screenshots which show from our own tooling what this can look like. So, all right. But before I show those screenshots, we're hiring. If you want to come and work with cool tech like Open Telemetry, Kubernetes, Cosmos, and a whole bunch of other exciting stuff, we've got all these jobs going at the moment. So get in touch with me. I'd love to hear from you. You can find all the code that you saw here on my GitHub, James-World. Very easy to find. I respond very well on LinkedIn. It's probably the best place to get hold of me, but I am also on Twitter, though not as much. And finally, here's what some of our dashboards look like at work. And the nice thing about Datadog is everything is very, very linked up. So although we're looking at metrics here, I won't show you now, but I can right-click on one of those graphs, and if I do that interactively, you'll get a trace coming up, which will look like this. And you can see here the effect of probably having a bit too many spans. I have picked a request that wanders a lot through various different systems. But certainly, this helps us get to the bottom of problems very, very quickly. And it's very rare that we have a bug that lasts long in production with this kind of telemetry available. So get on it. Get telemetry. It's worth it. And in particular, get Open Telemetry. This is the future of telemetry. There's absolutely no doubt that it's going to get mainstream support, and it's going to change our lives for the better and make us more empathetic with our users. Yeah. That's me.